Hello friends, and welcome to Escaping the Mouse with your host, me, Breck Roll. Alright, we are going to revisit the pool sweep issue again. You may recall a few weeks ago when I pulled the cover off of the pool and put the pool sweep in for the first time, it worked a couple cycles and then it stopped working. And I did a video where I took it apart to try and figure out where the problem was. Couldn't really do it, so I brought it into the pool place people, and they recommended that the problem was probably with the swivel latch. And they thought maybe I could just replace the cable. Well, that wasn't so easy to do. And I thought I maybe did a Band-Aid on it that would make it work until I could afford to buy a new one. But the Band-Aid didn't work. And so basically for the last couple of months, I've just been sweeping the pool manually with a net, and that's a little bit of a pain in the neck. I did do an improvise a couple weeks ago where I put a pool pump in there that makes the water spin and hopefully pulls all the solid material to the center of the pool, and that's helped a little bit. But there's some debris that's in the pool that's so small that it isn't big enough to be picked up by the currents caused by the water spinning. So I really would like to get the pool sweep running again. The problem is I got to get a new one, and it's going to be a little while before I can afford to do that. So I've been thinking about this, and I have a potential solution that will at least allow me to get the pool sweep going. It isn't a perfect solution and probably would make an electrician cringe, but I've had done something similar in another world that kind of helped fix this kind of an issue, and I think I can adapt that solution to this to make this thing work. Let me show you what I got in mind. I used to have low voltage lighting in my backyard in the house in California, and I had several different systems in there over the years, and they never really lasted that long. What it was is you'd have a power supply that I'd put in the garage, and then there'd just be a piece of electrical wire you run out to wherever you wanted to run the lights, and wherever you wanted to put a light, you popped it in the ground, and there'd be this little clamp that you would clamp over the wire, and it would have these little blades that would pierce the wire insulation and work their way down to the metal inside the wire, and that's how the electricity would get to it. But since this little metal piece was exposed to the elements, it didn't take long for that piece to rust out, and 6 months or a year later, the lights would stop working. So I started thinking I need to figure out some sort of a way to make this waterproof. And I started thinking about the cement that I use when I glue PVC together for like plumbing. And I realized, you know what, that kind of has a tendency to go on in a liquid form and then dry and become a nice, really solid waterproof coating around things. It's mainly designed, like I said, to glue PVC together. But I started wondering, you know what, if I clamp these little lights onto it and dip the whole thing in the PVC solution and coat the whole thing with this PVC glue, that would create an insulator around the metal and prevent water from getting in there and hopefully prevent the rusting that came along. And I did that one time, and it worked really, really well. It worked, and the lights I had in there, they worked for another 15 years because those connections weren't rusting out. And I started thinking recently, could I adapt that to creating a new connection that would protect the electricity going into the pool vac, and keep it protected enough that I could actually submerge it and make it work in the pool. And I've thought about it a lot, and I've got a suggestion on how to do that, and we're going to try it today. And like I said, this would probably make any electrician cringe, but I think this is going to work. So let me show you what we're going to do. Now, once again, it's more than 100 degrees outside, so I didn't really want to work in the garage, and so I've moved the vacuum inside the house here because it's nice and air conditioned. This is the problem area right here. This is the swivel mount. And basically, since the vacuum is supposed to kind of go back and forth in the pool and rotate around a lot like that, without this swivel mount, basically the cord will get coiled up into tangles and it'll be a big mess. This thing is supposed to prevent that, but this is where the system has failed, and it isn't making a good connection through this. So what I want to do is I want to cut it off here and here, reconnect it together. I'm going to solder the connections back together, and then we're going to use this PVC cement and some of this shrink wrap tubing to seal the area. I'm going to do probably 2, 3, maybe 4 coats of the shrink wrap with a layer of the PVC cement on each level, so that we've got multiple layers of waterproof protection on this. I'm pretty certain that this is going to work, and like I said, this thing is trash if I can't get this thing to work anyway, so you know, what's there to lose, right? Maybe I can buy a couple more months of use on this thing. And yes, there'll be the danger of the coil, you know, curling up. But what I can do is I can disconnect it from the power supply end right here and just untwist it. And I'll just have to do that. And that'll be a tactic that I can use to get some more life out of this thing. And, you know, maybe buy myself some time. So first thing I'm going to do is I'm going to cut this swivel mount out, and we're going to tear into the wire on each end, get everything down to the wire level, get it all soldered back together, and we're going to go from there. Alright, so I've cut off the swivel mount part. We're just going to throw that away. Yeah, that's why I don't play basketball. And basically what I've got now is I've got just the wire in here. It looks like there's a couple layers of insulation. So what I want to do is I want to strip back the insulation on this side, get back to where the wires are, and we're going to solder the connection together. Then we're going to use some of these little heat shrink pieces and dip it in the PVC cement to coat it, then put a layer of shrink wrap around it. Then we're going to put another layer of the PVC cement, and then I have a couple more pieces of shrink wrap that we're going to put around the outside of it to really seal it up really well. Like I said, I think that'll work really well here. So next thing I'm going to do is I'm going to cut a couple inches back on each side of this, strip off the insulation. Let's get back to the bare wire. Alright, so we've gotten the wire split up. It's actually pretty effective insulation they have on this, because there's actually 3 layers of insulation. There's the insulation on the wire, there's the inner insulation, and this outer insulation. So basically what I want to do now is I want to strip off about a 1/2 inch on each side of this. I'm going to tin that with solder it together, and then we're going to put some, going to dip it in the PVC cement to secure that, and then we're going to put a layer of shrink wrap around that and shrink that around there. And then we'll just going to do it 1 layer at a time here, and we're going to do multiple layers. I got about 3, maybe 4 layers of heat shrink we're going to put on this, so we'll see how this all works. Alright, so first thing we're going to do is we're going to tin the wire. With my handy dandy soldering iron. There we go. Now we're starting to get up to the heat here. Sometimes it takes a second for the wire to actually get to the point where it's warm enough to melt the solder. Yeah, now we're starting to get there. Sometimes you gotta let these soldering irons heat up a little bit before they get to the point where they do a good job here. Because basically what you want to do is you want to heat up the wire to the point where it's literally the temperature of of the soldering iron itself, so that the wire, basically all the solder just kind of turns into a liquid, and it just kind of coats the inside. You know, every layer of it kind of gets between the individual strands of the wire, so that you got a good electrical connection. Alright, so what I've done now is I've cut off a couple of pieces of shrink wrap and put it over the insulation. There's also a secondary piece of shrink wrap I put on here that I'm going to put over both pieces once I've sealed it closed, sealed the first layer. Like I said, I'm gonna solder this together. Then I'm gonna dip it in the PVC cement to kind of coat everything. Then we'll put the shrink wrap over that. We'll coat it again with the PVC. We'll put the shrink wrap over that. We'll coat that again with the PVC. We're going to put this piece of shrink wrap over that and shrink it into place. We'll coat it a fourth time with the PVC, and we're going to put this piece of shrink wrap over it. So that should create a multi-layer version that kind of keeps everything nice and waterproof in there, because that's going to be the big deal. Now, I'm not really worried about the voltage, because it seemed to me when I measured it, it was about 30 volts DC, which isn't really a huge amount of power, but it's still going to be one of those things I'm going to want to unplug when I'm in the pool, or at least pull the pool sweep out when I'm using that. So still want to be going to exercise caution, but I think it'll be unnecessary because we'll have everything really nice and sealed in there. Let's get going on the next step. Alright, so I got the first layer on. I soldered the two halves of the wires together, put the shrink wrap over it, shrunk it down. Basically what shrink wrap is it's a little plastic wrap like this, and basically what you do is you hit it with an industrial strength like hair dryer. You don't want to use this thing to dry your hair. This thing is designed to create temperatures at the tip of upwards of 1200 degrees. So that will melt your head if you use that for a hair dryer, but it's really great for this. And what ends up happening is when you use the shrink wrap itself shrinks around the wire and creates a solid seal. And the combination of that and the PVC cement that I've created inside should create a waterproof seal around this thing. And like I said, I'm going to do this 2 more layers on here. Going to completely coat this area here now with the PVC cement again, and then put the next layer of shrink wrap on, shrink that down, and then do the whole thing again and put a 3rd layer on. Alright, so I've got all 3 layers on. It isn't really that pretty of a connection, but it should be pretty well sealed now. I even put a little bit of the solution on the ends here to kind of seal the end up. So hopefully this should be working pretty well. I'm going to give it a few minutes to dry and cool off a little bit. We're going to throw it in the water and see if this thing works. So this is a garden right now. Tomatoes are probably about 4.5 feet tall. I got a flower on my okra, so I expect I'm going to get some okra out of this pretty quick. These okra plants are doing very, very well. They are definitely loving this heat, because it's like 101 out here right now. Good time to get in the pool, right? So I'll keep you up to date on that too. Alright, so I just threw the vacuum back in the pool, turned it on, and it is working again. So yeah, let's hope this continues. You know, there's always a possibility there may be a tiny little leak in there. Hopefully not. But at this point, you know, since there's no active electronics going on in this piece of the wire, if there is a problem, I ought to just be able to pull it out and it'll dry out on its own. But at this point, we seem to be back in business. Maybe we can get this pool to actually look nice now for a while. So anyway, I think that is all that I have for today. Thank you as always for watching, and I'll see you next time on Escaping the Mouse. Good night.